This video demonstrates how to enter data from an example project site into NCDOT JSLAT. The example presented in this video is of a relatively complex site with 4 BMPs. After you have determined that your project meets the rule criteria, have gathered the necessary project site data, and created the post-development site plan, you can begin entering data into NCDOT JSLAT. Our example site is an NCDOT facility that contains multiple buildings, parking lots, and driveways, among other land cover types. Our project area is delineated in red. The general drainage direction is from left to right. Runoff exits the project area at 2 locations on the right side boundary. This image shows the delineation of the pre-development land cover. And this image shows the post-development land use delineation. For this hypothetical project, 1 new building, along with 4 BMPs are proposed. The drainage area for each BMP has been delineated, and both pre- and post-development land uses have been delineated and tabulated for the site. Our hypothetical project has a hydrologic soil group of C underlying the majority of the project area and BMP locations. Land use data for the site's drainage area is entered in the Watershed Characteristics tab. To begin, select the Piedmont physiographic region using the drop-down menu. Select C for the soil hydrologic group, and select Raleigh precipitation location as the most representative weather station location. Enter the total drainage area for all the catchments. Enter a name for the site here, and enter your name or initials here. Next, enter the delineated land use areas. Our site is located in a predominantly non-residential area, so we will enter the data in column 1. Do not enter land use data into both columns 1 and 2. The example project is an industrial site consisting of multiple land uses, so we'll enter the pre-development land uses first. Empty cells are treated as 0 area in JSLAT. Enter the post-development areas, and JSLAT warns us that the areas do not yet match. This box displays 3 different areas: the value that we entered at the top of the tab, the total area we entered for pre-development, and the total area we entered for post-development. Our areas do not match because we have not yet entered the proposed BMP area, so we'll enter that data now. We see that the warning has disappeared and that the 3 values on the right match. Now is a good time to save your model. We have completed the Watershed Characteristics tab. Now we can proceed to the Bmp Characteristics tab, either by clicking the tab itself or by clicking the Proceed to Bmp Characteristics button. Land use data for each BMP drainage area is entered in the Bmp Characteristics tab. We'll begin by entering data for catchment number 1. So we'll select Dry Detention Basin for BMP number 1, which corresponds to BMP A on the site map. The BMPs in this example will be sized according to the NCDOT toolbox, so we will leave the sizing row blank. Some BMPs may be undersized due to limited space. In those instances, you will enter the appropriate value for each BMP here. Catchment number 1 is upstream and does not receive discharges from another catchment, so we'll leave these values set to no. Next, we'll enter the post-development land use area that is within the drainage area for Bmp A. Empty cells will be treated as zero area. We'll enter the area of the Bmp itself. The bottom of the table shows the total area for Bmp A and catchment number 1. We can use these values to check our work as we go. There are no other BMPs in catchment 1, so we can proceed to catchment number 2. For the type, we will select bioretention without IWS for BMP number 1, which corresponds to BMP B on the site map. BMP B receives discharge from catchment number 1, so we'll select yes from the drop-down menu. And we'll enter the post-development land use area associated with the Bmp B. Note that we do not enter any land use areas from catchment 1, even though runoff from catchment 1 can flow to Bmp B. JSLAT will account for this flow routing since we selected yes from the drop-down menu above. There are no other BMPs in catchment number 2, so we can proceed to catchment number 3. Again, we will select bioretention without IWS for Bmp number 1, which corresponds to Bmp C on the site map. Bmp C does not receive discharge from another catchment, so we will leave these values set to no. We'll enter the post-development land use area associated with Bmp C, and there are no other BMPs in catchment number 3, so we will proceed to catchment number 4. We will select wet detention basin for Bmp number 1, which corresponds to Bmp D on the site map. Bmp D is downstream of Bmp C, but any discharge from Bmp C is piped and cannot be treated by Bmp D. Therefore, leave these values set to no. Then you will enter the post-development land use area associated with Bmp D. Our site has no other catchments or BMPs, so we will leave the rest of this tab blank. To the far right, we see 2 additional columns. The right column lists the total area for each land use category. Values in this column correspond to the data entered in the Watershed Characteristics tab. The column to the left is a summation of the area entered on this tab only. For this example, these 2 columns should match, since there was no project area that did not drain to a proposed BMP. The far right column must be greater than or equal to the column to the left. If not, JSLAT will notify the user if a land use value is entered that exceeds the amount entered on the Watershed Characteristics tab. Now that we have finished entering data into the NCDOT JSLAT model, we can proceed to the model results in the Development Summary tab to confirm whether the nutrient targets will be achieved. The Development Summary tab provides estimated runoff and nutrient levels for 3 scenarios: pre-development, post-development without BMPs, and post-development with BMPs. The top table provides pre- and post-development estimated loads and concentrations. In this example, the annual runoff volume decreased from 1,254,154 cubic feet pre-development to 933,777 cubic feet post-development with BMPs. Nitrogen loadings were reduced from 11.85 pounds per acre per year to 5.49 pounds per acre per year, and phosphorus loadings also decreased from 2.57 to 0.94 pounds per acre per year. The lower table provides pre- and post-development differences by percent. In this example, the annual runoff volume decreased by 25% from pre- to post-development with BMPs. If no BMPs were used, then the runoff volume for the site would have increased by 1%. The use of BMPs reduced the post-development runoff volume by 26%. The net difference between the pre-development and the post-development loads was a reduction in nitrogen load by 54% and phosphorus load by 63%. Recall that only one, either the loading goals or the percent goals, needs to be achieved on the site in order to be in compliance with the nutrient strategy. If this site were located in the Upper New Hope watershed, then the current post-development plan would meet the percent reduction requirements, but would not meet the loading rate requirements. This site has an estimated percent reduction of nitrogen and phosphorus of 54% and 63% respectively, which is greater than the load reduction criteria of 35% and 5% for the Upper New Hope watershed. However, the annual loading rates of 5.49 and 0.94 are both greater than the required 2.2 and 0.82 pounds per acre per year. Because it meets the percent reduction requirements, it can be approved by NCDOT and DENR. The bottom BMP summary table provides runoff and nutrient results at the BMP level and the catchment level. In large sites with multiple BMPs, this table can help identify which proposed BMPs are the most effective. This table can facilitate an iterative design process by comparing alternative BMP scenarios. The BMP volume reductions / effluent concentrations table at the top right is for reference purposes and does not change based on the data entered into the model. For convenience, the JSLAT model results can be printed through the Excel's Print dialog or by clicking the Print Summary button. This video showed how to enter data from an example site into NCDOT JSLAT. Additional resources related to the NCDOT Green program can be found at the NCDOT Connect site.